Hello everyone, this is Ram Prasad Pujari and I welcome you all to another session on Python programming series, part 24. In this session, we'll look at decision tree machine learning algorithm. This is a non-linear classifier. Decision tree can be used for classification as well as regression tasks. But this session, we will focus on decision tree as a classifier. Now let us take an example to understand non-linear classification problem. Now in this example, the x-axis is the time in months, January to December, and y-axis is the geographical location whose latitude is given in degrees. So here we need a classifier to predict whether we can ski or not at a given geographical location and at a given month. So this is the northern hemisphere. So you have a positive angle, that is degrees, and then you have a southern hemisphere, and this is the equator. The northern hemisphere earlier months and later months are suitable for skiing, and for the southern hemisphere it is opposite. So we need a binary classifier to predict whether we can ski or not at a given location and at a given month. So this is a binary classification problem. But if you look at the data distribution, we can clearly say that we can't use a linear classifier or linear model cannot be used here. So these are the two different regions that we have. The region where for skiing and region where we cannot ski. So if you look at this data distribution, so we need a nonlinear classifier. So decision tree can be used to solve this problem. Decision tree is an example for supervised learning algorithm. It requires a data set with features along with the labels. There is also a non-parametric model, unlike other parametric model like linear regression, for example, because we have seen that the linear regression has an equation something like this, where the fixed number of coefficients are there, let's say a1 and a2, okay, so which are nothing but the parameters. Okay, so when any model has fixed number of parameters which are to be determined during the training time, then that model is called as a parametric model. Whereas a decision tree doesn't have a fixed set of parameters. Here the structure is flexible. So therefore, we call decision tree as a non-parametric model. To understand decision tree, let's take this example of loan application status. So here we need a binary classifier to predict whether the loan application needs to be approved or rejected. So there are two labels or two target variables. One is loan approved and the second one loan rejected. So this is a very simple decision tree where three features will be checked. One is credit score, second one is income, and the third one is debt to income ratio. Decision tree consists of three different types of nodes. Root node, which is the starting point of this tree. Now, in this case, application applicant's credit score will be evaluated. If the credit score is greater or equal to 700, the loan is approved. If the credit score is less than 700, we move on to the decision node. So where some decision has to be taken. Now in this case, the income will be checked, the income of the applicant, and if it is less than 30,000, automatically the loan gets rejected. If it is greater than $30,000, then we move on to the next decision node where debt to income ratio will be evaluated. So here in this case, in this decision node, if the debt to income ratio is greater than 40%, then the loan automatically will be rejected. If it is less than or equal to 40%, loan is approved. Now in this case, it depends on the data that we have. The decision tree takes different paths. So there is a very shorter path or the longer path It depends on the data that we have. Let's say if applicant has a credit score of 800, then automatically the loan is approved here itself. So it takes the shortest path. Whereas if the applicant's credit score is less, then it has to take several different paths. Depends on the income, debt to income ratio, etc. So this is how it is going to work. Now let us look at the demonstration. I'm using Google Colab for this exercise in order to construct decision tree. We need NumPy, Sklearn, Matplotlib. So these are the three important machine learning libraries that we need. So I will import this. Once you import this, next we'll have to load the data set. I'll be using loan approval data set, which is available on Kaggle, and this data set is in the form of CSV file. So we need Pandas machine learning library to convert this into data frame. Now I have downloaded this .csv from Kaggle, and then I have it in Google Drive, and also I have mounted the Google Drive on Google Colab. So I will read this data set. So this is the data set available on Google Drive right now. So pandas function can be used here. Now if you look at the columns, so let's just look at the columns. So we have more than 10 columns, around 12 columns that we have. And if you look at the columns, you can see that so this column name has a leading space. So this needs to be removed before we proceed. So as you can see here, so there is a leading space. So in order to remove this, we use either a Python function, or you can modify your CSV file and then we can use it. So this is the function which can be used to remove the leading space of the column name. Now after this, we can use a columns function, and you can see that the leading spaces are removed. So we have the data set now. So let us okay. So we use the head function to display first 5 rows, and you can see that these are all the features that we have, and the target variable is binary, whether the loan is approved or rejected. So there are two labels that we have. Now what is important is three of the columns have non-numeric data, so it needs to be converted into numeric values. Education, self-employed, these are the features which have non-numeric values. And similarly, the loan status column also has a numeric feature, or a non-numeric feature rather. So they need to be converted into numeric, and for which we use a label encoder. You can see that the label encoder is used here, and using label encoder, we can transform this. We can convert non-numeric column into numeric column, and we save it in the same column name. Now after this, we can see that we get all columns with numeric values. So you can see that this is converted into numeric values. So that is the next step. Now we need x and y. X will have the features except the last column. So we can drop the last loan status column to get x, and y will have only one column, that is loan status. Now we need to split the data set 80 is to 20 for training and testing, or training and evaluation. So you can see that we can use a train test split function. So this can be directly used. And after this, you can see that we get x train and y train, x test and y test. Now for the training, we use 80% of the training samples, and after training for evaluation, we can use the remaining 20%. In order to initialize this decision tree classifier, we use this particular function with the random state 42. So once you initialize it, we can train the model with xtrain and ytrain using a fit function. Now the model is trained. Now after training, we can perform predictions. So prediction is performed on a test data. So we can perform on the train data also we can perform, and we can calculate the training and test accuracy. So let's just take this line. We perform prediction on X test, and we get you know predicted labels, and then compute the accuracy score. So we have Y test, which is the actual labels, and Y predicted test. These are the predicted labels. Okay, so we can find the accuracy using this function. And so let us just print the accuracy of training data. So training data, of course, it has to be 100%, and even the test accuracy is around 97.4%. A decision tree uses a Gini index to measure the impurity of the data set, and the range for Gini index is between 0 and zero point 0.5. If the Gini index is 0, it means that is a leaf node. As you can see here, there are three nodes here, and here the Gini index is 0. So this indicates a leaf node. So since it is a leaf node, if there are 12 samples, all the 12 samples are approved. You can see that this value has two different labels. One is number of samples rejected, number of samples approved. Now in this case, number of samples rejected is 0, number of samples approved equal to 12. So when we calculate the Gini index for this example, then it's going to be 0, which indicates all the samples are correctly classified. So Gini index indicates the measure of, it's a measure of impurity, we can say, or it indicates the likelihood of misclassification. The lower the Gini index, lower will be the likelihood of misclassification. So if the Gini index is 0, it means all the samples are correctly classified. So you get a leaf node in this case. Otherwise, you get other decision nodes. Let's take this example to understand. This is a decision node where loan amount will be compared with some threshold, and we have 70 samples, and out of them, let us say this is 40, 43, 27 is the ratio of rejected and approved. So this is not a leaf node because all the samples are not correctly classified. So we will compute the Gini index. This is the formula that we use. Total number of samples equal to 70, 43, and 27 are the rejected and approved at this particular node. So the probability of rejected applications 43 by 70, and for the loan approved is 27 by 70. So when we calculate the Gini index, it's going to be 0.474. So this clearly indicates that samples are not properly classified. Okay, so from here it splits to different subsets. So that's how this is working. So Gini index is an important measure in the case of decision tree. Now in order to plot the decision tree, we have a plot underscore tree function of a scalar, so that we can directly use. So this is how this is used. Once the model is trained, we get the trained model, and you can plot this with the feature names, which are x dot columns, and the class names. There are two classes that we have, rejected and approval, and we can plot this.